Good morning, dear students. I have already completed 3 units in the classroom. Today, I am going to discuss 4th unit. The 4th unit is especially organic chemistry. It contains the organic chemistry. The organic chemistry, in this 2 parts are there. One is the reaction mechanism, another one is the stereochemistry. The first part is the reaction mechanism and second part is the stereochemistry. In the reaction mechanism, what are the topics involved in this? The first topic is the nucleophilic substitution reaction, and second topic is the Grignard reaction, mean addition reaction, addition of HBr to propene, Grignard reaction, oxidation reaction, reduction reaction, elimination reaction, and its mechanisms, and synthesis of aspirin and paracetamol. These are the topics involved in the reaction mechanism. So this is very useful for especially all the branches of BTech students. So different types of questions will come from definite questions will ask. At least we will get the 10 marks from the chapter. Okay, now today we have to discuss nucleophilic substitution reaction. Unit 4th, organic chemistry. Organic chemistry mainly 2 parts, divided into 2 parts. The first part is the reaction mechanism, and second part is the stereochemistry. In the reaction mechanism, our topic is nucleophilic substitution reaction. First, reaction mechanism. In this, first topic is nucleophilic substitution reaction. Nucleophilic substitution reaction. Nucleophilic mean nucleophiles are required. What are the nucleophiles are involved in this reaction? Especially hydroxide ion. It will come from any base, etc. Chloride ion, Br ion, cyanide ion, etc. These type of ions act as a nucleophiles. The nucleophilic substitution reaction, there are the 2 types of mechanisms are there, mean 2 types of reactions, SN2 reaction and SN1 reaction. SN2 and SN1. SN2 reactions mean bimolecular reaction, and SN1 is the unimolecular Now we have to discuss about the mechanism of the SN2 reaction. SN2 reaction. These 2 reactions, famous reactions SN1 and SN2, they are more useful in the organic synthesis. Many compounds involve this mechanism. Mainly in this bimolecular, two molecules, one is the reagent, mean that the nucleophile, another one is the substrate. Both the compounds involved. Nucleophilic substitution reaction mean bimolecular, two mean bimolecular, N is equal to nucleophilic, and S is equal to substitution. Bimolecular nucleophilic substitution reaction. Bimolecular nucleophilic substitution reaction. In the general reaction, alkyl bromide are example methyl bromide. Methyl bromide when react with the aqueous NaOH, aqueous sodium hydroxide, to form the methanol plus sodium bromide. This is the general reaction. And mechanism. The methyl bromide react with the aqueous NaOH. The aqueous NaOH form the sodium plus cation and OH minus ion. The OH minus is a nucleophile, and this OH nucleophile attack to the back side of the compound. This is the transition state. Here, the OH, the nucleophile, attack to the back side of the compound methyl bromide. Here, the OH ion is slowly sharing up a pair of electrons, to the carbon, and Br, the nucleophile, Br minus, is slowly leaving that group. Mean one is departure, one is attacking. The OH is shared with the carbon, the electron shared with the carbon atom, and it is a breaking of the electron, and two electrons taken away from the carbon atom. So this stage is called the transition state. Now after some times, this transition state slowly collapsed to form the compound, because the reason that these the partial hydroxide and partial two compounds Br minus and OH minus, both are partially negative charged ions. So one is attacking, another one is the breaking, mean leaving from the compound, and after sometimes it collapsed to form the compound. So it seems to be inverted compound. inverted compound. So optically pure compound is formed here. So stereochemistry, what is the stereochemistry involved in? Only pure compound is formed, that is the Walden inversion compound, mean inverted compound. Inverted compound is also known as the Walden inversion. Walden inversion. So this is about the SN2 general reaction and mechanism of this one. And according to kinetic theory, the rate is directly proportional to substrate and base, mean nucleophile. Base and nucleophile. The base is this compound, the OH, any OH is the base, and substrate is the methyl bromide. So the rate of reaction is always depend upon the substrate as well as the nucleophile. And according to kinetic theory, it is a second order reaction. It is second order reaction. And it is more favorable, the primary alkyl halide is greater than the secondary alkyl halide and tertiary alkyl halide. The primary alkyl halide gives the product more than the tertiary alkyl halide. So SN2 reaction, this is the general reaction. First write down the general reaction, then mechanism. Only single step is there. First attacking backside, OH is attacked to the backside of the molecule, and transition state and inverted compound. Only three molecules, only one step. And the rate of reaction according to kinetic theory, that is depend upon the both substrate and base. That is the reason bimolecular. The rate is depend upon the both the molecules called the bimolecular. And it is second order reaction, and it favors the primary, secondary. Primary is the more active than the secondary and tertiary, and these are the more reactive than the secondary than tertiary. Okay, take down. Now, after this, we have to discuss SN1 reaction. SN1, it is one mean unimolecular, nucleophilic substitution reaction. One is the unimolecular, N is the nucleophilic, and S is the substitution reaction. Unimolecular substitution reaction. Unimolecular substitution reaction. Here, the general reaction is tertiary butyl bromide. Tertiary butyl bromide, when react with the aqueous NaOH to form the tertiary butanol. Plus NaBr, Na sodium bromide. This is the general reaction. Why we are taking here tertiary? Because this reaction favors the tertiary alkyl halide, the greater reactivity than the secondary, than the primary. Whereas the SN1, the primary is greater reactivity than the secondary. And the rate of reaction depends only one substrate, not on the base. Only substrate. mean only one molecule. That is the reason it is a unimolecular. It is first order reaction. It is first order reaction. First order reaction according to kinetic theory. It favors the tertiary. That is the reason we have taken the example tertiary butyl bromide. Tertiary. This is the tertiary butanol. Tertiary butanol. Tertiary butanol. This is the symbol is the tertiary. Okay, now let's look the mechanism. Mechanism. Tertiary butyl bromide in solvent form the carbocation. Tertiary butyl carbocation or carbonium ion. And Br minus bromide ion is eliminated from this compound. Mean carbocation formation takes place. First, formation of carbocation. In step 1, this is the step 1. Formation of carbocation. Just in the solvent, just the Br minus is left from the carbocation, mean tertiary butyl bromide, and form the carbonium ion or carbocation. In the second step, the carbocation or carbonium ion this is very slow step and rate determining step. We can say rate determining step. And a slow step, fast step. So the nucleophile in the solvent directly attack to the carbonium cation to form the here optically inactive a racemic compound is formed, D and L, both racemic compound, but whereas in SN2 reaction only one pure compound is formed. Why? What is the reason to form the D and L in this reaction? According to stereochemistry, first of all note down this mechanism. This is the mechanism. Two steps are involved. The first step is a rate determining step or a slow step, and the second step is the fast step, and the cation attack the nucleophile to form the methanol compound, mean D and L compound. Please note down. Okay. Now, why it happened? What is the reason? What is the reason to form the D and L mixture, impure compound? Because the carbocation methyl group and methyl. This is the carbocation. Here, the three methyl groups, actually it is a sp2 hybridized. It is sp2 hybridized. Compound. sp2 hybridized compound. The three methyl groups are attached to the carbon in the same plane. The three methyl groups lie in the same plane. The three are lie in the plane. And the empty p orbital is perpendicular to the plane. The empty p orbital perpendicular to the plane. It seems to be equally available for the nucleophile. The nucleophile, it is equally available for the nucleophile, mean equally available. So that is the reason here two are available to attack. So both the compounds D and it is expected. It is a completely racemic compound. It expected compound, the D and L compound. Dextro and levo. D means dextro and levo. It is an optically inactive compound. But in the practical way. So what is the practical way? For example, here, this is the flask. We have taken the tertiary butyl bromide. And aqueous NaOH. So what happened? The Br minus is left from the butyl compound, and this is formed a carbonyl ion plus Br minus in the solvent. And in the solvent, it is the Br minus is closely proximate to this compound, the carbonyl compound. So it is available. So that is the reason here practically it is not possible, because we are not we have not purified this compound. The Br is available, sodium hydroxide is available, and nucleophile is available. Everything is available in the flask. This is the flask. This is the water bath and temperature. So then, Br is closely proximate to this compound and nucleophile also. So, but expected compound is the D and L, but whereas in practical it is not possible. The racemic compound is formed. Here, major compound, one of the D or L major compound 70%, and one is the 70%, or more than, or another is the 22.5% is possible. 22.5%. we know. Not 50-50, but expected compound is the 50-50, whereas in a practical case, that is not possible. So one is the major, another one is the less compound is formed. Because the reason the Br minus is available close proximate to the original compound. So this is the stereochemistry of the SN1 reaction. Okay, thank you very much. Today we have completed the nucleophilic substitution.